So, next part is composite function. So, if things are composite, it means there's made up of more than one. Yes, so if you have a composite function, it's made up of more than one function. And generally, you will see them with the two letters just next to each other like this. Okay, so you may see GF. I don't think in GCSE they have the circle in it, but just in case, if you ever see GOF, it means the same thing. Okay? Right, so now the order that these letters are written in is important. So if we see GF, what that means is that you're going to deal with function F first of all. And the reason is because that's the closest thing to the letter X. Okay? Once you've dealt with that function, you're then going to deal with the function G. Now, essentially, what you're doing is you've got function G, you are substituting in function F into that. Okay? So that's what we're saying. We're substituting Fx into G of X. So just how we had at the beginning of the functions topic, we had things like substituting in x plus 2 and a plus 2. We would be substituting in a whole function. Okay, so the order is important, that is the main thing. Now, when we have composite functions and they're asking us about numbers, actually they are nice and easy. Well, I think they are more straightforward than if you're keeping the letter involved. When there are numbers involved, we just have to remember which one to do first. So we're trying to find, first of all, f of 3. Okay, so we would find f of 3 in the same way we would any other way. How do we find f of 3?
3 plus 10.
No, f of 3. Anyone? Amelia?
3 squared.
3 squared, yes? Because you're substituting 3 into the function for f, yes? Are you with me? You did G.
Yeah, I'm not using G.
No, because there's two different letters, please. G and F. G and F. This is one question.
So 3 squared.
So f of 3 is going to be 3 squared, which is usually 9. Lovely. Now, we found f of 3. What we're now going to do is we're going to substitute that value into G. So we're now going to find G of 9. Do we see what we did? We found f of 3, and we're now substituting that into G. Okay? So we're going to now say that that's 9 plus 1, which is 10.
Then do you add it on it?
That's it, the end full stop.
You don't do anything?
No.
Has it together?
No, because we found this value here in order to substitute it, oops, put it in the wrong place, in order to substitute that in. Yeah? Now, this is to show you that the order makes a difference. So this one is FG3. Okay? So the order is important. First of all, we need to find G of 3 for this one. So G of 3 means we're substituting the value of 3 into G this time. So we've got 3 plus 1. Which is 4. Then what are we going to do?
F of 4.
F of 4. So we're sticking 4 into there. So we've got F of 4, which is 4 squared, which is 16. Okay? So they give you different results. So the order is important. You deal with the one that's closest to the letter or number first, and then whatever value you then go into the other one. Okay, so if you've got numbers, it's just 2 steps. Okay, find the value of the first one, stick that value into the second one. If they're x's, however, you can't do that. Okay, so what you're going to do is you're going to substitute the whole function into the other one. Okay, so we are going to find G of fx. So when it's G fx, we're finding G of fx. That means that we're having G brackets x squared. Do you see that? Because x fx is x squared. That means that wherever we see an x in our original function for g, we're now going to write x squared. So it's going to be x squared plus 1. Our final step is always to look at that and see if we can simplify it in any way or expand anything. Can we do anything with that?
No.
No, so we would just leave it as it is.
But don't you do the one that's closest? So it could be f.
If you're substituting in values, you deal with whatever is closest to the answer first. But we have no value to substitute in, so it's just a straightforward function. So that function for fx is being substituted into gx. So the function of f of x is being substituted into the function of g of x. So f of x was x squared, g of x was x plus 1. So this is going to go in place of anywhere we see an x in this original function. Yeah?
Wait, wouldn't it be the other way around?
No, because f goes into g.
Which is g going x?
No.
Because f is closer?
No, so the f1 goes into the g one.
But then why didn't it go into the g for the others?
Well, it did, but we actually worked out the value of it. We worked out the value of the fx first, and then substituted that in. Yes? No?
It's fine, I'll get it out.
Okay. So this one, it's the other way round. We're going to substitute in g into f. So this one is going to be f brackets gx. So wherever we see an x in the original function, we're going to write whatever we see as gx. So this means it's going to be f brackets x plus 1, is it?
Yeah.
Which means it's going to be x plus 1 squared. Now, I say, can we expand, simplify? If we expanded that, it's no simpler than the original format. If there had been additional expressions or terms, then maybe you would expand it and simplify it, but we can leave that one as it is, just like that. Okay? Remember though, if you were going to expand that, write your two brackets out, because you need to use FOIL if you're expanding a bracket like that. Okay? But we can leave it like that. Now, just to confirm that we did them everything the same, this is our expression for gfx. This is our expression for fgx. If we were finding gf of 3, what we could have done is found this expression here and then substituted in the value of 3. So if we'd wanted to, we could have then said, right, I've got my expression, I'm going to stick in the value of 3, so that would be 3 squared plus 1, which gives me 10. So you get the same answer, it's just that you found your general expression first of all. Okay? Wow, I'm getting a lot of enthusiasm.
Yes.
Okay.
Strong yes.
Here's some examples. Alright, so let's go straight into solving an equation f gx equals gx. Now, we have to look at the original information. Do we know what f gx is? No. So the first thing, in a similar way to when we had this one here, it said, where was it? Solve h minus 1x equals 6x. We had to find the inverse function first. So in a similar way here, we need to find an expression for f gx first of all. So f of gx, I'm going to write it like this. Okay, so so I'm just dealing with that first of all. So f of gx means I'm substituting into the substituting gx into fx. So that means that I'm finding f of 2x minus 3. Okay, so gx is going into fx, which means that I'm substituting in 2x minus 3. So wherever I see an x in this original function, I'm going to write 2x minus 3 instead. So I'm going to have now 3 lots of 2x minus 3 plus 1. Right, I'm just going to let you look at that and make sure that you're understanding what's going on here. So the g goes into the f. I've established what g is. It's 2x minus 3. So wherever I see an x in my function for f, I'm putting that expression, not just the letter x. Is that clear? Anyone got questions about that?
Wherever you see x.
So wherever you see the x here in this function, f, I've put this whole expression instead. So instead of 3x plus 1, it's 3 lots of 2x minus 3 plus 1.
Oh, okay, yeah.
Yeah? Anyone else? Layla?
Why are you using the F if it's the G in this?
Beg your pardon? Why am I using this one instead of this one?
No, why are you using, like when it says equals 3 bracket 2x, is that the F?
It's, yes, so here my function f says 3x plus 1.
Yeah.
And we know that when we have something else here, that is written instead of the letter x. So if I was trying to find f2, to straight for f2, you would write 3 brackets 2 plus 1, yes?
Yeah.
You agree with that?
But why is it not the G?
This represents g.
Oh.
So we don't use the letter g, we're using the expression for the function g. Is that what you're asking?
Yeah.
Yeah? Everyone else happy with that?
Yeah.
Yeah? Now, is it likely that we would ever leave something looking like this?
No.
So we need to do some expanding and simplifying. So everything in my bracket is multiplied by 3. So we've got now 6x minus 9 plus 1. And then we've got minus 9 plus 1 gives us minus 8. So we've got 6x minus 8. Okay? Now, we might think, oh, well done, we're finished. Unfortunately not, because that's just establishing f of gx. Okay, so that's just establishing what this side of the equation is. We now have to make sure that that's equal to gx. Okay, so this is f gx. We're now going to say that's equal to gx. So we set 6x minus 8 is equal to gx. Oh, I've just drawn a line all over it. 2x minus 3. Okay? Because it says solve the equation f gx equals gx. So I've established what f gx is. Yeah? And that has to be equal to gx.
Okay, so you figure out what f and gx is.
Yeah.
So now I just
So that's that bit, that's that side. And so then we're going to write it is equal to gx.
okay.
Yeah, and now we're going to solve. Yes? So we're going to need to join the x's together. I've got fewer x's over here, so I'm going to take 2x from both sides. So I've got 4x minus 8 equals negative 3. Then we're going to add 8 to both sides. So 4x is 5. X is 5 over 4. Isn't that the same answer as 3 over 4?
Yep.
That's weird, isn't it? Okay, to make sure you understand that. I think we're going to do the next example next lesson. Okay? So far so good?
Yeah.